Hello, everyone. Going to give just a couple minutes to let people continue to come in, and we'll get started. I hope you guys are having an excellent hackathon. Great. Make friends. That's the most important part. Make friends. I'm going to put my LinkedIn also in the chat. If anyone's interested in connecting with me and building their professional network, feel free to connect with me there. But this is me. Okay. I think it's a pretty stereotypical thing not to build your network while you're in school, and then you start to get towards the end and you say, oh, I really need to build a network to get a job. So it's definitely something better to start thinking about sooner than later, and conferences are a really great resource to be able to meet and network with people in a relevant field to your interests. And I'll talk about that a little bit later. People are still coming in right now. All right, it looks like things have slowed down a little bit. I think we can go ahead and get started. So my name is Blaec Bajarano. I'm the Chief Sales Officer for CoCalc by Sage Math Inc. And today I'm going to tell you a little bit about our platform, primarily in the context of using it for scientific computing and learning about tools in the open source ecosystem like Python. But I'll go ahead and share my screen. Let me get started with that. Okay. So you should all be able to see my screen right now, and I'll take you over to CoCalc.com. So if you would like, you can sign up for an account literally right now. You just put your email address and make a password, and then you're off to the races. You can use the free version of the platform. So if you're interested in exploring any of the features as I go through this demo, it will be a lot more engaging and interesting for you guys. So please feel free to do that. And if you have any questions, you can, I'll keep this little side chat open. So you can ask me any questions there as we go along. I'll try and glance back at that as much as I can to see if you guys are engaging and interested in anything specific, and I can dig into it a little bit more. Okay. All right. So CoCalc.com, sign up with an email address, make a password, and then you have projects. So projects, these are virtual workspaces. So you all are participating in a hackathon. You know exactly what it means to have to collaborate with a group of folks that want to code together. And as you continue throughout your educational experiences, you might want to do that for homework assignments or working with an advisor at your university, or any other any other scenario where you might want to be able to code or even write a publication with someone else. So what you'll do is you'll create projects with different sets of collaborators to determine who has access to what files and what computational resources. So I'll click on my first project, and this is a shared file system. And I'm curious how many of you guys are familiar with Linux. So if you're familiar with Linux, this is going to feel excellent to you. This is a full Linux file sharing system. In fact, you have a mini terminal that's located in the upper right-hand corner. So you can use terminal commands. So you can see I can use ls, or I can use top, etc. So that's just one thing that I'd want to mention there. And if you want to have a full terminal, you can click on the Linux terminal button. So there's create a new file. So I'll click on terminal. And now you do have that full terminal experience where you have the ability to, run a whole host of different commands in a terminal, connect to different file types. This is the list of file extensions that CoCalc supports right out of the box. So pretty much everything under the sun, they're all open format. So you can always download these files back out and run them locally or somewhere else. Okay. So now one thing that I really want to point out here, though, is we have Jupyter notebooks. How many of you guys are familiar with Jupyter notebooks for interactive programming? So something like Google Colab. Okay, so I'll click on Jupyter. And in fact, I'm going to generate a new Jupyter notebook. And I see someone has their hand raised. So, okay. So a couple people are familiar. So I will go ahead and click AI, help me write this. So I just want a nice little template for us to get started, and then we'll handwrite some things. But we have integrations with language models. So you can use AI models like GPT, Gemini, Mistral, and Claude. So some LLMs here. And they're both free and premium models that you can choose from. So even at the free tier, you have the ability to choose, let's say, GPT 4.1 mini. Okay, and I'm going to use that. And now here are the programming kernels that you can choose from. So these are all right out of the box. You can, of course, include your own kernel as well. So these are some of those. And you even have version control for some of the kernels, which is pretty nice. But I'm going to write this in Python. And I'm going to say, let's say, create a script that plots, or let's say that uses SunPy to plot solar data and give some relevant information about the data being displayed and some of the mathematics involved with further analysis. Okay, and now what I want to say here is create math equations using LaTeX. And I'm just going to say in dollar signs just to make sure it works. Okay. And here is my brand new notebook. And I can look through it first before I actually save the notebook. So you can see here's importing some packages, and here's our AIA map for some of that sun data. So an AIA 171 angstrom image. And now we create the plot, and then here's some of the math that I was asking for. And it looks like it's doing some interesting 2D Fourier transform of the intensity data. So now I can go ahead and click save. All right. And now I have my new notebook. And the one thing that I'd want to make sure that I emphasize here is that CoCalc is real-time collaborative, just like Google Docs. So if you want to work with someone, you can have that Google Docs type of experience, but while working together while coding inside of a Jupyter notebook or, in fact, a terminal. Let me go ahead and run this. So let me run all cells and make sure that works. So I need to import SunPy. That's not right. Let me see. Oh, of course. guess SunPy is not already included in the environment, so I can create a bash command. So let me do that. So I'll make a code cell and I'll pip install this. So let me do pip install SunPy, and now I'll click run. All right. And you can see I'm using this AI help me fix this functionality as well. So I can copy again the command and I could run it in bash. So let me do that. Okay. And I guess you can see here's our nice image. So there was an error, and I can go ahead and give this a try really quick, but it did give me a nice output. All right, there we go. And now you can see I have some nice external information around the plot. And then lastly, so you can see a nice Fourier amplitude spectrum of the solar intensity. So this is, again, just a quick example of what you can do pretty quickly with AI using our Jupyter notebooks. And one fun thing that I could say too is the notebooks are also interactive. So if you want to use widgets, you can do that. So maybe I want to say, create a plot of, let's say, population dynamics between rabbits and coyotes. Again, just an example. And make it interactive using IPy widgets. Okay. So now I'm going to generate this code cell. And what's really nice about this, sorry, this isn't the way. All right, what's really nice about this is you'll get these widgets, and even the widgets are real-time collaborative. In fact, let me go ahead and do this. I'm going to fix this. I'm going to use a more advanced AI model and see if it can do a better job. So we'll use GPT 4.1 and ask. Okay. All right, so we'll give this a try. Run it. And now you can see I have these nice sliders. And if you're interacting in real time with your collaborators, you can actually see updates to the sliders in real time as well. So you can explore something together, which I think is pretty neat. So I did want to mention that as well. And you do have a side chat. So you can see I've been interacting with the language assistant in the side chat, but you also have the ability to call over your collaborators. So the one thing that I haven't shown you yet is how to add those collaborators. So what you'll do is you'll head over to the user panel on the left-hand side, click on that, and add the email address of the person that you'd like to add as a collaborator to your CoCalc project. And then they'll be listed here, and then they'll have access to the shared workspace with you. So they'll have access to that shared file system. Okay. So does anyone have any questions so far? I am more than happy to answer any questions and make this as interactive as you'd like. But if you want to, you can shoot me a message in the chat and I can answer those as we go along. Okay, great. Okay, so let me go ahead and move on to the next thing. So I'm going to handwrite a couple lines here, or maybe I'll ask a couple questions about this first. So maybe I don't understand what was generated here. Okay, so I just generated a lot of things, and I could look through this a bit, but maybe I want some additional comments, or I want a quick explanation about what some of the packages or variables do here. So let me go ahead and click on the Assistant tab on the code cell, and then I can choose the AI Assistant and have it explain this code cell to me. So now I'll go ahead and ask, and it gives me that overview of the underlying architecture of the problem, what each of those variables, components, and packages do. And similarly, maybe you're working with someone that is using R and you're working in Python or another programming language, or maybe Python and Julia. You have the ability to translate between programming kernels very easily as well. So here, maybe I'll do that exactly with R. And now I'll ask. And you can see it's using the R kernel. And one really neat thing about the side chat is that you have the ability to run code as well. So this generated code, I can make sure that it actually works appropriately before I port that over to the production level notebook on the left. So maybe here, I'll even say, hey, GPT-4 4.1 mini, or actually I'll use GPT 4.1. Let me go ahead and do that. So we can do something a bit more complicated. And let me say, create me a script that plots a, let's say, 3D wave equation using finite differences, which is a numerical method. Okay. And give the LaTeX equations in $. Okay. So here's my wave equation. And it's using R since that's what I was previously working in, but let me go ahead and ask for it in Python. Translate to Python. Okay, and now it's using the Python kernel. And I can make sure that this actually runs appropriately. So here, let me go ahead and click run. So it didn't give me a very nice output. No output in the grid. And you have the ability to experiment with these kinds of things. So here you go. And now it's telling me to try the improved version. Paste it, run it. And it still didn't work. Okay. So maybe I'd need to work on this a bit more. And for demoing purposes, I will probably not do that, but I'll give it one more shot here and I'll just say something like this. Let's say create a random walk and iterate on this 20 times. Okay. So this is a bit of an easier problem and hopefully it can handle that. Great. So here is a random walk with 20 steps. So that is a quick little example of how you can plot in the side chat before you actually port that code over. So now I can easily copy it and paste it, explain it again. Okay. Similarly with the, again, the help me fix this functionality. So if you get an error, you can ask and get a nice little overview on how to get your code back up and running again. And then if you'd like to have a conversation with the model about your entire notebook, you can click on the assistant in the upper left-hand corner, this little orange button here. And then you can ask questions about a particular cell, a selection of text, all of the notebook or none of it. And then there's some nice little examples that you can choose from or just do full-on prompt engineering here. Okay, so that is just a really quick tip on that. And you can video chat in CoCalc as well. So if you go to view, you can video chat with each other using Jitsi. So just know that there are a whole host of different tools that are available for you in that context. And then lastly, I'll make a fun little map. So I'm located here in Seattle, Washington, and I could say create an interactive map using IPy leaflet. And use, let's say, Seattle, Washington as the location. Okay. All right. And now you can see I have this nice interactive map that I can play with. So it can be very useful for geosciences. It can be Jupiter can be very useful for mathematicians or statisticians or physicists, people that are studying molecular biology or bioinformatics. These are all people that I personally work with in the kinds of communities that I engage with and go to those kinds of conferences and showcase the platform. Okay. So there are tons of different options and lots of viability for using Jupyter as a tool for scientific computing. Definitely from a learning perspective as well. It's pretty easy to get set up, and you can always use things like Jupyter Lab or VS Code to run Jupyter notebooks. Okay, so I just want to make sure that I mentioned that. And if you are interested in using traditional notebooks like Jupyter Classic or Jupyter Lab, you can access those very easily by going to servers and then going to notebook servers here. So you can also use VS Code. You could use Pluto if you're a Julia fan, or RStudio if you're an upcoming statistician. So there are, again, a whole host of different options for different IDEs and code editors for you to be able to use. Okay. And now one thing that I want to also quickly show here is you might question, how many of you guys are familiar with GitHub and how to use GitHub? I'm hoping many of you are familiar with such tools. But if you're interested in version control and what that looks like for real-time collaborative documents, you can absolutely use GitHub inside of CoCalc. So I'll split my screen really quick. So let me go ahead and do that. So I'll split my screen, and maybe I want this to be a terminal. So you have a full terminal here to be able to use. I have no idea why this is down here, so I'm going to report that. But I do have a terminal. It does still work. And you can see here's top, or I could use htop. In fact, let me go ahead and clear this. So clear. Okay, and what I want to show here is you also have the ability to use Git through your command line. So that is absolutely possible. And in addition to version control via Git, you can use time travel. So I'm going to handwrite a couple lines below. So I'm going to create a text cell. And I'm curious how many of you are familiar with Markdown as a formatting language for text format. So you can use Markdown here for text formatting. But you also have a nice WYSIWYG editor too. So if you don't know Markdown and you want to just use a nice little toolbar, you can type and highlight and things like that here. So maybe here I want to use some bold. This is bold. Okay. I can highlight text and of course use that. Okay. And now one other thing that I'll go ahead and point out here too. Let me go ahead and do this. I'm going to use some LaTeX, and I'll say sigma minus nu is equal to gamma. Okay, so you can get some nice math formatting. You can include links or images, so it's pretty fun to be able to use as well. You can change the colors of things. So I can go ahead and do that. Let me highlight this. Maybe you want this to be red. That's pretty strange. I did not like that, actually. Oh, I see. Okay, go ahead and delete that. See if it worked. It did not. All right, interesting. Okay, and now let me go ahead and handwrite a couple more lines. So I'll do A equals 2, B equals 3, and B minus A, just to handwrite a couple things. And what I really want to show here is when you click on time travel, you'll even see my me playing with this, but here, let me go ahead and use that. So you can see me handwrite these lines right here and say, Blaec, I really like what we were doing. And this is the same for the code cells, of course. So I really like what we were doing up to revision 172A, but let's go ahead and revert back to this previous version and build on top of that. And if you're really lost in the weeds and you can't figure out for the life of you what went wrong where, what did I change in the last couple minutes that horribly broke everything, you can see exactly what's changed in JSON format with syntax highlighting, and you can iterate throughout the document in that sense too. So there's some nice collaborative features here for folks that want to be able to have version control, and you can see what's been going on while you were away. Okay. All right. So another thing that people might be interested in is if you guys are working with language models, or maybe you're doing machine learning, or you're trying to learn about these kinds of things and you need access to GPUs, or maybe you want access to a more powerful machine than what you have locally, you can click on the server button. So you can click on new compute server. And now I can choose from Google Cloud or HyperStack or self-hosted resources like my own local laptop or server, or maybe I have a billing provider that I want to work with, like maybe I have a Google Cloud account and I got some credits somehow and I want to be able to use those. You can do that by clicking on self-hosted. But we try and make your life easier when we can. So you can use our API integration with Google Cloud. You can say, hey, I want to use a spot instance, or I want to use a standard instance. So if you're not familiar with that terminology, spot instances can be killed at any time if someone decides to purchase that instance at its regular rate. But while it's not purchased by someone at a regular rate with a standard instance, they make these spot instances available at a highly discounted rate. So you can get really powerful machines for pretty cheap, which is great for experimentation if you're on a budget. So I'll go ahead and click on Spot. You can see that there is a little GPU switch here, and you can choose the GPU types that you'd like, the number of GPUs, and then you have images for machine learning software like PyTorch, TensorFlow, Google Colab, Llama, CUDA, and JAX. And then the machine type. So here you can choose the exact machine type that you'd like to run with the GPU, and where's this data center physically located, what's the cost associated with the exact location, and where you have lower carbon emission rates. So that's also a really nice feature. But you can reduce latency by having that data located physically near you or that compute server. You can also connect directly to the compute server using VS Code or using Jupyter. So those are some things that you can do once you spin up the server. And of course, you can continue to use CoCalc and any of the features here. But let me go ahead and just show the other machine types really quick. So if you turn the GPU switch off, you have some more images for standard scientific software like Python, Sage Math, which is the programming. It's actually a computer algebra system that our CEO and founder had created in 2004. And I'll talk a little bit about that here in just a minute. But there's access to Julia, HPC environment with Fortran and Slurm. You can experiment with Kubernetes or RStudio. So all of these things are available for easy install on the compute server. And then you have the machine types, everything from the smallest E2 micro instance for a fraction of a penny per hour up to just really massive machines, probably the largest machine you'd ever probably want from Google Cloud with almost 12,000 gigs of memory and 416 CPU cores. So each and everything in between, some really great value machines for around 10 cents an hour. Just as an example, you can see here's a machine for 10 cents an hour with 64 gigs of memory and 16 CPU cores. So pretty powerful machine for a really good price. But yeah, so that's what I would want to mention there. And once you spin up one of these machines, and let's say that you're working in a notebook or you're working with a terminal, you can click on the server button, and then you can choose the active compute server that's listed in the dropdown, and you'll be able to run your script remotely on that new virtual machine. Okay. And the other neat thing, especially for a hackathon or for people that are interested in having access to the underlying infrastructure for the compute, when you spin up one of these compute servers, unlike the full CoCalc service, you do have sudo rights, and you also have root access to those machines. So you can use sudo or use root privileges to do anything that you want with that machine. Okay. So that is one other thing that I'd want to make sure that I mentioned there. And now I'll dig back into a couple other features. Does anyone have any questions for me so far? I haven't got any questions for a minute. I'd love to know if you guys have any questions or if you're interested in anything particular that I've shown so far. Okay. Not getting a whole lot of response, so I'll continue. Okay. All right, so I'm going to head over to the plus new button. And one thing that I would also like to show you guys is if you head down to the whiteboard or to the slideshow mode, this is pretty neat. So you have the ability to write using a pen and a tablet like an iPad. I'm not actually sure what Flutter is. I will have to look that up. Give me just one second. I'm happy to answer that. If it's installable via Linux, you can install it and you could probably use a prompt. But I'm not actually sure what Flutter is. If it's another language model, it might be something that you'd have to use on a compute server. Okay. But I'll go ahead and I'll continue with this for just a second. So you can see here is a pen that I can write with. So you can write using a pen and a tablet. You can make sticky notes using LaTeX Markdown or rich text. So here is again that rich text WYSIWYG editor that I can use to make some sticky notes. So I could say here is a quick sticky note. And maybe I want to include a little bar there, and maybe I also want to have some markdown, and I'll use a little bit of LaTeX. So again, I'll use my classic sigma minus nu is equal to gamma. Oops, gamma. You can see I have some nice math formatting there too. So that's really the value of using LaTeX, and I'll talk about our LaTeX editor as well. But here is a nice little sticky note, and you can drag those around. But one thing that I would also want to point out here is that you can create Jupyter cells. So here I can choose from different kernels. Maybe I want to use Sage Math just as an example. And I'll just write plot sine of x. Well, there's my plot. Let me go ahead and snap that. Okay. Let's do something a little bit different and just get some output. I'll do 2 plus 3. Okay, so you will get some output there. One thing that I could also show as well is you can make these little frames, so you can organize things in different ways. You can use different colors, which is pretty nice. There are little icons and stickers that you can use. So I could put a little text sticker here. Okay. The other thing that I could point out is if you make multiple cells or notes, etc., you can connect them with edges. So you can make edges between the cells. Let me go ahead and do this. And similarly, slides work in the same way. So let me go ahead and make a quick little plot here. I'll use Python, sure. Actually, I'll use Sage again, and I'm going to try this. Doing a bit of experimentation right now. Okay, so here's my nice plot. So you could actually run code for people in real time during your presentation. I'll go ahead and delete these. And make some little notes. And you can make multiple pages. And then you could go to view. And you have slideshow. So here's the slideshow mode. Okay. So that's just a really quick example on that. And now I'll exit out of these frames really quickly. Okay. So if you're not familiar with LaTeX or Markdown, there are full LaTeX and Markdown documents that you can create here. I typically use Markdown documents unless I'm making something a bit more formal. But here's a nice little Markdown document that I could get started with. And again, you can use all of that kind of formatting. And then you have this, rich text version that's over here on the right-hand side. Okay, so those are some things that are really easily accessible for you. And then the other thing that I'd want to say as well is here's a LaTeX document. In fact, I might just generate one really quick. So this will give me a pretty basic example of a LaTeX document. But let me go ahead and I'll create one. So I'm going to click on the AI help me write this functionality. And now I can choose an example. So maybe I have a lab report, or maybe I want to make a resume. I'll do a resume. And now I'll just copy and paste some things from my LinkedIn. Let me do that. All right. Great. And now I'll click on Create LaTeX. All right, and you can see I just generated a resume for myself very quickly, and then you can modify this and you can continue to ask questions about it. Of course, you could just go into the LaTeX source here and you could adjust these things as you'd like, but you do have the ability to create professional looking documents using the LaTeX editor and the integrations with our AI assistant, okay? And I'm just curious, how many of you are familiar with LaTeX? Or is this your first exposure to LaTeX? So LaTeX is pretty much the, I would say, the king when it comes to scientific publications. So if you are interested in pursuing like academia and science, it's highly likely if you're in one of the hard sciences like chemistry or math or physics, that you'll end up using LaTeX pretty profusely, okay? But it does make really nice looking resumes, especially if I was to actually like tune this myself. But yeah, so that is one thing that I could point out just in terms of good tools to be aware of, right? Okay, and since many of you, I'm sure, would probably be interested in eventually hosting an event, or maybe you'd be interested in teaching something, you could have the ability to manage a class. So what I wanted to do for our workshop was use this course functionality, but unfortunately we were unable to collect the email addresses beforehand. But essentially what you can do is you can create a course. So I'll click here and it creates a course file. And now what I would like to do is I can add some email addresses. So I'll just add some additional emails that I have. So Blaec, let's say Blaec Alexander +2@gmail.com. Okay. And now I can search and I can add this person as a student. And now they're listed, and you could use a comma delineated list or copy and paste the CSV file column of email addresses, so you can add everyone at once. You don't have to add them each one by one. And then you have the ability to create assignments and handouts. So an assignment is just a folder with an arbitrary collection of files inside. So you can create folders with some files in them, and you can distribute them out to the class. So I could say, hey, I want to give this assignment 1 out to everyone. So I'd add the assignment. And then I can assign it to the entire class or to a specific student. You can have a due date, peer grading. You can collect from the students as well, and you can leave annotated comments and feedback. You can grade things. But if you're interested in even just distributing content, this can be a really nice thing for that. So if you want to give people handouts, you don't have to necessarily grade or collect anything in that context, but you can give each person that is listed as a student, or maybe in our case, it would have been workshop participants. You can distribute a a collection of files out to them, and that way everyone has something that they can experiment with, and they can have a streamlined and a pretty coherent experience. Okay, so that's essentially what this is all for and what that's about. And you can run terminal commands in all student projects at once if there's maybe a package that everyone needs to be able to do an experiment. The other thing that I'd mention here too is there's a ton of different configurations, so you can adjust that email invitation that everyone will receive when they join your course. Okay, so that is one thing that I could mention in that sense. And you also have the ability to disable certain features and functionalities if you feel like those are irrelevant for your workshop. Okay, so that is that. And now I'll head back over to the plus new page. All right, so there are a couple other things that are pretty fun that I could point out here, like X11 graphical desktop. So I'll go ahead and do that. So here is X11 desktop, and you have the ability to run command lines here. And you also can use any of these little push button functionalities to launch things in the visual editor on the right. So this is the graphical desktop. So you have your code editor, some applications, and then here's the graphical desktop on the right-hand side. Okay, so I'm going to use xclock just as a quick example. So I'll use xclock. So you can see I've got my nice little clock here. You can actually launch Firefox. So it'll take just a second, but this should launch Firefox for us. And you'll have a web browser. So there are various applications that you might want to use inside of CoCalc that would require you to have a graphical interface. Same thing with things like, let's say, TechMaker, or if you're familiar with like Emacs or Vim, those are all things that you can use here. Maxima, Ideal. So you have each of these different code editors that you can select from. Okay, so let me go ahead and let me just type in Firefox. I don't know why that's Firefox. Let's see, I feel like I'm just forgetting the command. Let's ask how to launch Firefox via terminal command in X11 desktop. Okay, so we'll just give this a shot. So it says it's not installed, so something obviously needs to be adjusted here. And that might actually be a bug on our side. And I see someone had just raised their hand. Do you have a question? Maybe it's a mistake. You can type in the chat if you have a question that you'd like to ask, and I'm more than happy to answer anything that you want to throw at me. Let me go ahead and try and launch something else and see if this is more of a widespread bug. There we go. So here's the ideal shell. So it's just the Firefox icon for some reason isn't working. But you do have the ability to launch various applications directly inside. Maybe I'll use LibreOffice just for fun. Just discard this. Yes. Okay. So you can see I had some Super Bowl tweets that I was playing with previously. But that is LibreOffice, and you have the ability to use any of the tools that are available there. But it's just an interesting application to be able to play with. And if you need a specific graphical interface to be able to run code, this can be a helpful escape hatch. No worries, Abtar. Do you want to just type in the chat? I, of course, could try and install Firefox. I just don't want to do that right now. Let me go ahead and close out of these things. Let me just go ahead and do that. Okay. Now, what else? So another thing that I could quickly point out as well is our VS Code integration. So if you want to have access to VS Code, you can do that very easily. So let me go ahead and click on servers, notebook server, and VS Code. So this is launching VS Code in a separate tab in my web browser. So I can click trust here. And now I have my shared file system, but I also have access to all of the extensions from the VS Code ecosystem. Okay, so you have a lot of flexibility that you can use there in terms of being able to do some of these things. Okay, let me go ahead and I'll open. I know I have a notebook around here somewhere. Where is it at? Is this it? Yeah. So here's that notebook that we created earlier, just so you get a sense of what Jupyter looks like inside of VS Code, if you're not familiar. But here is that nice image with the VS Code editor that everyone knows and loves. Okay. And here were some of our experiments. All right. So similarly, you can do this for Jupyter Lab. So if I wanted to click on Jupyter Lab, this will launch Jupyter Lab in a separate tab in my web browser, and you have, again, access to the shared file system, but you have the same editor and same interface from Jupyter Lab that maybe more folks may or may not be familiar with. Okay. So here is traditional Jupyter Lab. Okay. And here's some fun examples that I was working on before. All right. Okay, so now I'm going to pause my demo here for a minute, and I'm going to switch gears up, and I'm going to talk about a couple things, mainly around trying to engage with the computational science community. There are lots of them, but I think that this is some valuable advice, and I would really like to give it to you. There are a couple other things that I could probably show you in the platform, specifically around like project activity. So you can see who's been active in your project. You can see who's eating up your CPU right now and how much disk space or RAM do you have left. So these are all nice features, and there's some nice settings and some other customization that you can do. So I could click on dark mode just as an example, and maybe I want to use a different editor color scheme. So maybe I want to use Dracula just for fun, and maybe I want a different terminal setting for my color scheme. So I could use something like Raven. Okay, so these are all different things that you can do in order to adjust your experience using the platform. So I do want to mention that, and you can also publish very easily. So if you're inside and maybe you've created let's say a resume, or you've created a Jupyter notebook that you'd really like to make available. For instance, I can do this with the example notebook that we've created earlier. I could click here, and I can click on publish. So I've just selected the file. Now I'll click publish, and I can make this public and unlisted. So I can give someone a URL link, and then they'll have access. Or I can click on public listed, and then this will be available indexed via Google, and then anyone can search it online. But I'll go ahead and click on public and unlisted. And now I'm going to share this link with you all in the side chat. So you could see this if you clicked on the link. And I'll go ahead and head over here myself. But you can see here is that Jupyter notebook, and you can easily download this. So you could download this locally and be able to run this wherever you'd like, or you could edit your own copy inside of the CoCalc platform and be able to make your own adjustments, etc. So there's some nice little sharing things that you can do too. So, all right. Now, the last thing that I could just mention in terms of like who we work with and who does this, who publishes using the CoCalc share server, is we work with Cambridge University Press. So here is the Journal of Fluid Mechanics by Cambridge University Press. So while you're reading through the journal at cambridge.org and you see a simulation and you say, wow, this looks great, I want to try this out for my own purposes, I want to experiment with that code, you can click on the hot link, and this takes you over to the CoCalc share server. And then you have access to the Jupyter notebooks and the data sets that belong with that research publication. You can click on it, you can look at it, You can edit your own copy and again, download it locally. And we do this for full-on 3D fluid dynamics. So you don't have to rely on like a static plot to try and figure out what the simulation's doing or just try and run it yourself. You do have the ability to just easily interact with the code and the simulations right out of the box. So that's pretty nice for scientific exploration and discovery, and also just general reproducibility. So being able to reproduce experiments is extremely important, and having a tool like this where I don't have to pull a GitHub repository, fully configure the environment just to be able to run someone's code to be able to compare the results and then modify it for my own purposes is pretty nice. So that is just a really quick thing that I'd say about that. So I wanted to make sure I didn't forget that. Okay, so again, switching gears over to conferences and how you can engage with the computational community. There are a couple different things that you can do. So I would highly encourage you to join any community that seems like it's relevant to your interests, and there are a lot. And I'm going to start naming some over here in the side chat, so you can just so you can be familiar with them, and maybe you can Google them. In fact, maybe I'll go ahead and I'll do that. So I will just use my Google search bar, and that way I can just put the links in for you. So there is the American Mathematical Society. So American Mathematical Society, same thing with the Canadian Mathematical Society if you're in Canada. So American Mathematical Society, so AMS, and this is their homepage. So if you're interested in mathematics, this is an excellent organization to be a part of. So I'll go ahead and throw this over here. And let me go ahead and point out the joint mathematics meeting, which is the largest conference hosted by the AMS. So you can see this, the next one will be in Washington, D.C. this year. So I will certainly be there. But there is the joint mathematics meeting. It's a really fantastic community to get engaged with if you're ever interested in exploring advanced mathematics or like mathematical programming, etc. Those are definitely the people that you'll want to start to build your network with. And then one other thing that I can point out as well, and just in terms of math, is the Mathematical Association of America. So what is that? The MAA. So MAA Math Fest. So here we go. And let me go ahead and click on this. So this will be in August. So this is right around the corner. So MAA Math Fest. And I would say that this is, they're both very oriented towards high school and undergraduate students. So there are lots of those folks roaming around. And in fact, I think that they have a day that's open to the public. So if you just happen to be located around where these events are happening, there's even a free day for you to be able to show up. And I'm pretty sure it's not so expensive for folks your age to be able to go. So that is one thing that I would mention as well. If you're interested in astronomy, the American Astronomical Society, so AAS, let's say, I think it's 247. Let's see. So this is the next AAS meeting. So this is again, the American Astronomical Society meetings. So if you're interested in astronomy, these are really great conferences to go and engage and interact with people. And I will just say, so you understand the value of showing up physically in person to these events. This, I would have to encourage you, is the best way to go shake someone's hand and smile at them and give them a pitch about what you're excited about and what your kind of intentions are for your education, to be able to have someone specifically to mention in your letter for your undergraduate degree or for your future graduate degree or for your future job. So building these kinds of connections can be extremely valuable just in terms of having kind of that inside person to be able to even just ask questions to, even if you can't necessarily rely on them to help get you the job. They can be great resources to ask and kind of give you guidance as far as like what the expectations and requirements are to give you a better chance of being accepted into a program or to get that internship or to get that job. Okay, so I just wanted to make sure that I emphasize that. The other thing that I could point out here as well is, let me go ahead and I'll write the American Physical Society. So APS, APS, March meeting. So it's actually the Global Summit now. So Global Physics Summit. So here it is, and this was for 2025. So I'll just go ahead and post this one in for the future one. So March next year, it's going to be happening in Denver, Colorado. So if you're interested in physics or applications of physics, maybe quantum computing, that could be something interesting. Maybe just to try and make things shake things up a little bit, I'll go ahead and point out the NVIDIA GTC conference, which happens in California every year in San Jose. So this could be a really good conference if you're trying to get into tech. Okay, similarly to things like Google Next. Google Next. And AWS reInvent. Okay. I will say, I think GTC has been my favorite conference that I've attended this year. So Jasmine, I will say that those clips that you've seen, the hype was real. Everyone there was very excited to tell you about the projects that they were working on. But I would highly recommend applying to go. And there are tons of different, I think there's a lot of financial viability to be able to go if you just write them a letter. So I would just encourage you to reach out to as many people as you can if that's something that you really want to do. I bet you that someone could get you in fairly easily. So that is one thing that I would also mention. Supercomputing would be a really good one for you guys. So supercomputing for IEEE 2025. So this will be in November. So here is that. This is another one of my personal favorites. And if you're interested in Earth and space science, AGU is another really big one that I'll be at. So the American Geophysical Union, so 2025, and this will be in New Orleans, Louisiana. NeurIPS is a good one if you're interested in machine learning. Actually, next week I'll be at this. So there's the International Conference on Machine Learning, ICML. So this is going to be in Vancouver, Canada next week, and I'll be exhibiting there. So if you happen to be around, come visit. And then NeurIPS. Okay, so these are all good organizations to be familiar with and to try and get your foot in the door with. If you're interested in trying to pursue any of those, or you just had a specific interest, maybe I didn't touch on a community that you have a specific interest about, maybe like biotechnology or let's say like aerospace engineering. Those are both communities that I'm also pretty familiar with and would be happy to have a conversation. And you all have my LinkedIn. But I will I'll pause now for any last minute questions. I'll go ahead and yield the floor now. But yeah, I'm super happy to answer any last minute questions that you guys have. Okay. And I'll stop sharing. For attending conferences is the best way to through cold DMs. I would certainly say no. Okay, this is exactly what you should do. Connect with people on, I would say where you DM someone is and how is very crucial to this question. If you are writing people on LinkedIn and you're engaging with them in like a personable and meaningful way, like you see that they're engaging at these conferences that you'd like to be a part of, I feel like that's a very easy segue to like DM someone and be like, hey, you know, I noticed that you go to these conferences. I'm just curious how I can get involved too. Volunteering. Volunteering is the best way for folks that are financially constrained to go. So I would highly recommend volunteering. That, like, for example, SciPi happened this last week in Tacoma, Washington. And if you were interested in going, but you didn't have the financial means, which was like, I think it was a few $100s for a student to be able to go. It was like $300. I don't know about you, but like it's, I might have $300 laying around every once in a while, but there are not that many events that I'm going to go to that I'm going to spend $300 on. That's like a pretty expensive concert, so you could have the ability to volunteer, and you would have been able to attend for free. So that is definitely something that you can do. Same thing for supercomputing. You're very welcome. Thank you very much for attending. Yeah, the other thing that I would say too, just in terms of good ways to network with people, the last little carrot that I'll leave you with: Meetup, Luma, and Eventbrite often have tech events that are happening locally around your area, and they have free events. If you look them up like far enough in advance, like maybe like a month out, you can get early bird tickets that are free, and you can just show up and attend some of these events. And that's a really great way to meet some of these people that go to the conferences, and go shake their hands and get to know them and let them know that you're someone that's interested. But yeah, that's some advice that I would give, just in terms of like being able to actually go out and meet people in person. Volunteering and like physically showing up is a really good way to go as well. So those are some things. And if you're starting college, reaching out to like your department and asking your department for opportunities can be a really useful way to go about those things too. So thank you all. Thank you very much. Thanks for your time. Exactly. Yes. So people will pay. Your college does have the ability to potentially pay for a trip to a research conference or to an academic conference. So that's definitely a really good point. So thanks for throwing that in, Harish.